When you're first learning recursion, it can be hard to connect the dots on why is this important? This feels like more work than just looping or iterating with a while loop or a for loop. And what's the point? And as I've alluded to before, when we're learning recursion in the way that we are, the first goal we're trying to get across is just comfort with the idea of a function being able to call itself and make progress towards some goal. And doing this in the context of a singly linked list is one of the most concrete and simple ways of getting some of these fundamental concepts down. But it's admittedly not very exciting. So I wanted to show you a more practical example that hopefully you'll find a little bit more interesting. And the problem that we're going to address is how do we visit or get a listing of every single file in some directory? And we'll do this within the context of our workspace, right? But you can imagine you're in some job, you've collected a lot of data, you've organized that data into a bunch of directories, and now you want to write a program that goes and runs through all of the directories, maybe all of the children directories, and processes every file in this way. This type of problem exists in security concerns where we're checking where you need to scan every file to see if it has some virus or malware. Some recursive process is going and checking each file. When you copy a directory from one place to another, when you make a backup, say, recursion is going to take place there. The same type of idea is going to have to go through every file and folder, and every folder within a folder, and folder within a folder, and so on. And what we're going to do is try and list out, and I've actually simplified down my directory structure here, so I don't really have many lessons here, but you've got a number of lessons, you've got a number of exercises, and other files in your VS Code. How can we actually print all of the contents of our file system into our program? And from there, you could imagine, well, now that you have the list of all the files, you can go and process all those files. I've set up some starter code here, and what we're doing at the top is importing some functions from our standard library. I'd like to talk about those first. So this function, from the operating system package, and this package is cool because it works for a number of different operating systems. This would work if you were on Windows or on Mac, and it kind of hides or abstracts away, I should say more specifically, the details of each of those platforms, such that we have one function that will allow us to list all of the contents of a single directory, right? So this function will give us back what's in a single directory. And then when we use the term path, the path is a string that encodes a directory. And so to give an example of this, you've probably seen in the terminal in VS Code this workspace path and this starting slash. Well, in the context of our dev container, it's kind of an isolated system outside of your operating system. This is what we would call a top-level directory. And if we were to list using the ls command, what's in this directory, we get a listing of, you've got your lessons directory, you would have an exercises directory, welcome.py. Some of these things we hide in VS Code, like the tools directory, we hide that because you don't need access to it, but you make use of that when you're making submissions on Gradescope. There's some special things that Python's doing called caching to make things more efficient. But if we were to pop out, readme.markdown, readme.md is there, welcome.py is here, lessons is here. But if we were to list, the path here is /workspace, we could also do it like this. And if we were to say /workspace /lessons, we would see, okay, here are the two files that I've currently got in my lessons directory. You would see a much longer list because you've built up many more lessons over this course, and so on. But this is a path, right? So this is this string is sort of encoding a directory structure. And if we were to look on my Mac, here I've got open my workspace, and here's my lessons directory. Here are the two Python files I have in it. You could imagine something very similar. Cool. And so the path is just a string that references that refers to a directory. It can also refer to a file, but in this case, we're going to start from a directory so that we can list its contents. So I'm going to give you a chance to catch up and be sure that you've got the same code that I have here. And we'll talk through these functions when we need them. All right, so in this traverse function, this is going to be a recursive function because when we reach a directory, right, here we're in our top level directory and we're going to see, okay, we've got 2 files that we care about and then we've got multiple directories. Well, we also want to go search those directories and traverse them and list their files out. I've gone ahead and added print statements that will help us get a sense of this recursion. So when we enter this function, we'll see that we've entered traverse being called for a given path, and then we're going to exit it. What's the first thing we need to do? Well, we need to get a list of the files in this path. So let's try doing that. So we can get a list by saying, children is a list of stir. And we get that by asking or calling the list dir built-in function with this given path. Right? So our path is workspace, and that's where our work on our dev container is stored. So if we save this, we should print this out. Print children. You'll notice we get a list literal, and it has some hidden files. Right? So what you're going to see here, and I'm going to try my best to explain away without being too confusing, is in our workspace, we actually have, if I were to go look at this on my Mac, and I don't have hidden files showing on my Mac either, so I'll show you in the terminal. There's a special command for ls that is --all. And there's a certain kind of file, if you prefix a file name with a dot, that causes it to be what's called a hidden file in this operating system. And so we don't typically see these in our sidebar or even in your directory, depending on your settings on your Mac, and you might see them on Windows, but they are files that are there nonetheless. So these aren't coming out of thin air. These are files that exist, but they're kind of used for, I could show you real quick. So code.flake8. This is a file that sets the setting for the max line length. So if you've ever been told your lines are too long in VS Code, if you change this to 120, you would get that error to go away. So they're just files that are storing some settings. We can ignore them, and we actually probably do want to ignore them. So we'll work on that in just a second as we're filtering through. So why don't we actually do that? So we're going to write a for loop for child in children. And let's just go ahead and, ignore the things that we don't care about. So if child, which is a string, index 0 is equal to a dot, that means it's a hidden file, or child index 0, the first character, is equal to an underscore, we're going to do nothing. Else, let's just print this out. Print child, right? This terminology of children is can feel a little bit foreign and crazy when you're first thinking about a recursive tree structure. But because this is a tree, we think of a root node as a parent. So our root node is going to be our workspace. That's our directory. And we see, okay, once we've filtered this out, we see that, okay, we're not seeing any of those hidden files that begin with a dot or those that began with an underscore. The underscore ones are more Python specific, like the cache. Once we filter those out, we're just ignoring that. We're doing nothing. This is what we call a no op in computer science, which is a no operation. We're not going to do anything. We're just kind of ignoring it. Otherwise, we're printing this child, right? And we do see the other files here, right? So we see README, we see this directory, we see lessons. So these are lessons as a directory, starters a directory. In my particular project, tools as a directory, you'll have it too. You'll have exercises in here as well. But notice there's directories and files mixed together. So the next thing we kind of need to do is to test, is something a directory? Well, it turns out that we've got 2 functions that we're importing from path. So remember, path relates to this string that's saying this is a directory structure. And one of the first things we want to do is join this part of the path with whatever our child's name is. So let's make this, let's set up a variable named full path. And that's going to be a stir. And we're going to join our path that we're currently searching through. This is our traversal with our child, right? And let's print this just to see what we're working with. and what this join function is doing. So notice what it's doing is, in our example, it's putting a slash between these two values. Now I mentioned the difference between Windows and Mac and Linux and Windows and these things. Well, on Windows, Windows uses a different slash. It uses the backslash instead of the forward slash. And so what this join is doing is it's being sure that regardless of which operating system you use, we're going to use the right thing. Now, everyone, whether or not you're using Windows or Mac, you're going to see forward slashes in our output here. And that's because this dev container is actually running a special version, a special operating system inside your operating system called Linux. So you're running this on a simple little Linux machine, virtual machine, I should say. Right. So notice we've got all these paths, and now we want to test, and thanks to the join. And so join is like a slightly more advanced concatenation. We could have done, path concatenates with slash, concatenates with child, and it would have worked in this example, right? We would see the exact same output. But when you're working with files and directories in paths, if you want to make your program one that can run on many different operating systems, you want to use join instead. Right? These are the types of concerns you start to worry yourself with when you're writing real programs that other people might use on many different platforms. Well, now that we have this full path, we kind of want to know, am I working with a file or a directory? And so we've imported this other helper function from os.path package, and we see that isdir is a function. And we could search for this. So let's try, but basically we give it a directory, we give it a path. So if isdir full path, visit a dir. And dir is short for directory, of course. Else visit a file. So when we visit a file, what do we want to do? We just want to print it out, right? Print full path. And if we were to save this right now, we've still got work to do. What we'll see is, we only have the 3 files here. So we enter our workspace directory, and we only have 3 files: readme, welcome.txt, and then one that we're hiding from you in VS Code, but does exist, is pyrite config. So if I were to try and open, I'd have to do it from here. Trust me that it's, we're this far along. Pyrite config.json. This is just some settings for our VS Code as well. We hide it because there's no real benefit in changing it. We've set up those settings for you nicely, but it is a file that's there nonetheless. That's why we're seeing it here, right? So these are the files in our top level directory. Well, how do we visit the subdirectories or the children directories? And here's where I want to give you a chance to try calling traverse recursively with full path as the argument. All right, so let me get out of the way and give you a chance to try this. Once you've successfully implemented this, save it, save your work, and then go check your output in Trailhead. All right, so let's give it a shot. So here, we're trying to call this function recursively. So traverse is the function we're calling, but the path is no longer just path. We're not going to call it on the same path. Otherwise we'd have infinite recursion. In fact, we could try that and prove it to ourselves. So we save this and we try, we go about 982 function calls, and then we see, somewhere down in here, we should see that infinite recursion problem. Yeah, there it is. Maximum recursion depth exceeded. So this is infinite recursion because when we traverse, we're not actually making forward progress. We're not moving into each directory one after the other. So what do? Well, we're trying to, full path represents the path to a subdirectory, right? We've just joined the current path with the child. We know that that child is going to be a directory. So now let's traverse that child directory. And we do this, and you'll see, much longer output. And if we take a second to consider what this output is, let me move this over. Notice we enter workspace, and then we enter workspace tools. Your order might be slightly different, but that's where mine went next. And notice within tools, we see that there's 2 files that get printed out. And then we exit the tools directory. And where are we? Well, we're back in workspace. We print out, pyrite and readme. Those are the next 2 files that were found. And then in my example, we're entering the starter directory and then the starter EX06 directory. And that's where, I had placed some code that you're not going to have in yours. But then we exit those 2 directories. And we enter the lessons directory. You'll have many more lessons than I do. We exit the lessons directory. We reach the welcome Pi file. We enter, in my example, the challenge questions, but you're going to have exercises and others. And if we think about, what's going on here, well, our program starts at our top level directory, this one, and then it says, okay, let's go check lessons. Let's print out our files and lessons, and then we're done with lessons. So let's go back up. Then let's go into starter. Let's go into EX06 and go into and print compsogram and support and so on. And if we were to make more subdirectories, like in my lessons directory, if I were to make another subdirectory named, foo, and make a file named bar.txt, we would see here, let me rerun this program. Enter lessons, we enter lessons foo, we see that we have this foo bar file, we exit lessons foo, we have one more file in this directory, then we exit lessons, and so on. Right? I'm actually going to delete this so that it's not there anymore. But hopefully what this example gives a sense of is the ability to use recursion to solve a real problem that you might have. You might really want to write a program that processes every single file in some directory and all of its subdirectories. Maybe you're looking for the largest file. There are some special functions if you were to search for how do I determine the size of a file. This is a great example of how can we iterate on a program. So find size of file in Python. This is a fine way to go about it. Geeks for Geeks is a fine site. You'll notice that oftentimes as you get more comfortable, you can import a top level package and then use the dot operator to get a little bit more specific. But notice there's a get size function in os.path. Well, we're already importing join and isdir from here. So let's import get size as well. And so maybe we want to print, full path. And let's actually make this an f string. So f string full path. And then in parentheses, we'll print get size of full path. I'm assuming that this is how the get size function works. And it says return the size of a file, and we give it the file name, and it says, it's going to be a file descriptor path. And let's try this out. And cool, we see, some of these files are larger than others. So, the submission.py file is 4,000 lines, or not lines long, characters long. Readme.markdown in workspace. So if we were to open that up, we'd see, yeah, there's, a good number of characters here. If I were to select all, I don't actually know how to quickly get a character count, but we can trust that there's about 2,933 characters in there, give or take, and so on, right? And so, very quickly, we could look for, maybe we write another test if a file is larger than some specific limit. Let's print that out or look and see what that is. You could imagine if you wanted to convert, resize a bunch of photos, and you had, all of your travel photos, you wanted to make smaller versions for thumbnails or something like that. You could write a recursive function to move through every file in a tree of directories and so on. And just to sort of bump up to a higher level, notice this is a different looking pattern in a sense than the pattern we saw with a singly linked list. Nevertheless, we can identify some key concepts. One of the first key concepts is our recursive case. So notice that it's not in every case. In fact, many branches, we don't do anything. So in the case where we found a file name that was started with a dot or an underscore, we ignored it. We didn't do anything. In the case where we found a child that was a directory, that was our recursive case. Otherwise, we had another base case here. So it's not always so clear that you put your base case at the very top and then you handle your recursive cases after that. Here we did have one base case at the top, but we also had one following our recursive case. We could reorder these if we really wanted to. If not is dir, we could have done this. There's probably a function that tests for if something's a file, but is dir is nice and pithy. And the other thing that's fascinating that we haven't spent much time with, but we're going to trace an example of this because it's an important concept to understand, is notice that this recursive call happens, and then once we've returned from this frame, we're going to come back and we're going to print exit. So notice there's a pair of matching enter exits, and they kind of surround the directory that we just traversed. So enter workspace, well, we don't exit that until the very end, right? We've got all this work that happens between the first function call for workspace where we print that path and then we print exit that path. Well, the whole recursive process that plays out on our stack, enters workspace tools and then exits workspace tools, enter workspace starter, exit workspace starter. But inside of that, we went into and then back out of a directory. And similarly, we're going into a frame for traverse when we call that function. And then once we finally are done with this, notice there's no returns in here. This is a function that returns none. We just exit and we continue on our way. So that's something that we'll try out in a diagram very soon. We won't try and diagram something of this complexity, but this is an example of a real world application of recursion. So great work on this.